property of the Laplace transform that we will prove now is called linearity. So basically it says that the Laplace transform of a linear combination of two functions is that same linear combination of the individual Laplace transforms. So we're talking about a general linear combination of two functions. So that will be something of the form alpha f of t plus beta g of t. And so what I said was that the Laplace transform of this function is in fact the corresponding linear transformation of the individual Laplace transforms. So let's call this a proposition, and this should hold for any values of the two constants alpha and beta, and for any pair of functions f and g, what will we say that possess Laplace transforms. So obviously this is only going to work if the functions f and g themselves have Laplace transforms. Now we can prove this by using by a straightforward use of the linearity property of integration. So let's try and prove this. Take the Laplace transform of this linear combination of functions. Okay, and according to the definition, this is the integral from 0 to infinity of e to the minus st multiplied by this function. I'll just drift over to the left here to give myself some room. So we keep half an eye on the result we're trying to prove, what we're trying to end up with. We're trying to end up with the linear combination alpha times the Laplace transform of L plus beta times the Laplace transform of G. And that should guide us in the manipulations we make down here. So I hope it's clear that we should multiply this exponential term into this bracket, and we can rewrite this as alpha times e to the minus st times f of t plus beta e to the minus st g of t, and this whole integral is done with respect to t. And now we can use the linearity property of the integral. So here we have an integral of a linear combination of terms. So we can split the integral up like so. We have alpha times the integral of the product of the exponential with the function f plus beta times the integral of the product of the exponential with the function g. Okay, now stop for a second and just look at what we've done. We've got alpha times this integral here plus beta times this integral over here. But of course, this integral we're looking at here is nothing other than the Laplace transform of the function f. And this integral we're looking at over here is nothing but the Laplace transform of the function g. Just scroll up a bit. Hey presto, that's the result we were trying to prove here, right at the top. So you can finish off and say, as required.